let us all look at this question. So we are given the unbalanced equation. Here it is. And the question reads as follows. The thermite reaction between the iron oxide and magnesium. This is the iron oxide. This is the magnesium that they are talking about. It produces an iron metal. This is the one, the iron metal they are talking about, and the magnesium oxide. So by the way, this is the reaction that they are talking about. So we are also told that if a mixture of 20 grams of each, meaning that 20 grams of each, 20 gram, 20 gram, 20 gram, 20 gram, right? In other words, each has 20 grams. It's used. The first question now, it says balance the chemical reaction. So to balance the chemical reaction, if you check it out here, how many Fe do you have? You have 2. Here you have 1. So 2, 1, meaning that it's not balanced. So we can't reduce this 2 to 1. Instead, we can just let this one be 2 so that we can have 2, 2 both sides. Meaning that we can write 2 here like that. From there, if you check it out, we have O3 and only one O, meaning that we are forced to write 3 here so that we can have 3, 3. Let me write plus like this. And if you check it out now, how many O do you have? 3. Here you have 3 O. Then what about here? How many Mg do you have? You have only 1. There you have 3, meaning that you are forced to write even 3 like this. So when it is like this, it is now balanced. So another question, it says, which one is the limiting reactant? Which one is the limiting reactant? So what is needed, or what you need to check it out, is that remember this one that is written on the left hand side are the reactant. This one that is written on the right hand side are the product. So when they said which one is the limiting reactant, how many reactant do we have? We have 2 reactant. We have first reactant, second reactant. In other words, this is one reactant, this is another reactant. So among these 2 reactant, which one is the limiting reactant? And I know majority of people usually use the number of moles to see which one is or is the limiting reagent, or which one is the smallest in terms of the amount that react completely. So now this is what you can do. First, you can now find the molar mass first, right? Let's say the molar mass of what? Let's find the molar mass of the first one, Fe2O3. So by now you should be familiar with how to find the molar mass. If you are not sure how to find the molar mass, you can check out my previous video. You will find how do we find the molar mass. So 159,7 gram per mole. This is the molar mass of the first one, right? The molar mass of the second one, which is this one, the molar mass of magnesium, or Mg, is going to be 24,31 gram per mole. That's the molar mass of this one, right? But let's calculate now the number of mole of each. Number of mole is equal to mass over molar mass, right? Which is going to be, if we start with the first one, this one, what was the mass is given here, right? It's 20. So the mass was 20 gram divided by what? By 159,7 gram per mole, and then the answer gives us 0.1253 mole. From there, remember this is for Fe2O3. So now for this one, the number of mole is going to be again mass over molar mass, which is going to be 20 gram divided by 24,31 gram per mole. This is going to give us 0,8231 mole of what? Of Mg. Now, let us look at our balanced equation. Remember from our balanced equation, 1 mole of this, can you see 1 mole of this? It reacts with 3 mole of what? Of Mg. Remember, we have 1 here. We just don't write it. We have 1 here from this stoichiometric. If you check it out, stoichiometric, it says 1:3, isn't it? And then here we have 2:what? Is to 3, like this, right? From the stoichiometric ratio. So now, 1 mole of this one, it reacts with 3 mole of Mg, right? So in other words, required mole of Mg will be simply being the number of mole of this one multiplied by 3. So the number of mole that is going to be required is going to be 0,1253 mole of what? Of Fe2O3 multiplied by what? By 3, which is going to give us, this is what is supposed to be required, this is what is required actually. 3759 mole of what? Of Mg. So if you check it out, this simply means that the one that you got here, it's way too big than this one, meaning that now we have 0,082 mole of Mg available. Which is more? Which is more than needed, right? Look at it in this carefully. What is required in this reaction for Mg was supposed to be 0,378. This is what was required, or what is required. However, Mg, if we check it from here, it has more because this one is more. So if Mg was supposed to have this, but instead it have this more, it simply means that it's not a limiting reagent, the Mg, because it has more. So meaning that our limiting reagent is going to be Fe2O3 is going to be our limiting reagent in this case, because if you check it out, it has more than what is required. What is required? It was supposed to have this, but it didn't have this one. Instead it has more. So that's why we are saying it's the limiting reagent is the other one. Now, what mass of iron metal can be produced? If you check it out, let me erase this one quickly. Let me erase here quickly. If you check it out, we want to find the amount of this one produced. 1 mole produce 2, right, of the iron that they're talking about. Then what was the number of mole of this? We will multiply it by 2. So the number of mole is going to be 0,01, no, not 0,0, but instead it's going to be 0,1253 mole multiplied by 2, which will give us 0,2506 mole. This is the mole of Fe that they are talking about. Let me erase this one so that things may not be messy. Yeah, so it's like this. So Remember the number of mole, this one, we know it, we have calculated it before. So from here to here, we multiply by 2. That's why I multiply by this 2 to find the number of mole of what? Of this one here, which is the number of mole of Fe, right? So to find the amount, we now need to find the molar mass of Fe. So the molar mass of Fe, you check it on the periodic table, you will find out that the molar mass is 55,85 gram per mole. So if we have number of mole and we have the molar mass, it's easy to find the mass because mass is the same as number of mole multiplied by molar mass. So what is the number of mole? Number of mole, we calculated it, right? It's 0,2506 mole multiplied by the molar mass is this one. It's 55,85 gram per mole, right? From there, the answer becomes something like 13,99 gram, which is approximately 14 gram. So yeah, so in other words, the mass should be 14 gram, the mass of this ion that has been produced.